All right. When we left off yesterday, we had figured out that h of x was our mystery inverse function. We had gone through proving that through our use of algebra. Okay? Now, I want to ask you, does every single function have an inverse? If a function is what we call one-to-one, then it has an inverse. If it is not one-to-one, then it can't have an inverse. All right? A one-to-one function is one-to-one if for a and b in its domain, if f of a equals f of b, then that implies that a equals b. Can I photobomb your picture? Okay. A function has an inverse if and only if it is one-to-one. So, let me ask you, this graph right here, is that function, the red line is a function, is it one-to-one? No, why? Why is it not one-to-one? Ben, I didn't see your quiz yet. Do you have it with you?
Yeah, let me find it.
You're right there. You're right there. I think you... That's a good test. That's a thing. The horizontal line test is a thing. It is a thing. And Morgan, you're right there too. So it says a function is one-to-one if for a and b in its domain, if f of a and f of b are equal, then that means that a must equal b. Let me ask you this. That point and that point. F of, what is that, 1/2 and f of 3.5. Are those 2 points equal? They look like it. It looks like about 2.5 for each of those. Okay? But it says if those are equal, then these 2 points must be equal. And are they equal, Ben? No, they're not. No, they're not. So this is not an even function. And Kaylee had a really good intuition about how to test for this. And that is with the horizontal line test. What is the vertical line test for? Whether or not a relationship is a function or not. A horizontal line test tells me whether or not a function is one-to-one. Okay? One-to-one. So let me ask you this. Can an even function be one-to-one? No. Not possible at all? Well, even functions are, parabolas are even functions. Well, is the absolute value function an even function? Yes. So are even functions necessarily parabolas? Sometimes they're these. Pretty much is 10 because is x cubed one-to-one? Yeah. X cubed is one-to-one. It passes the horizontal line test. Are all cubic functions one-to-one? Not necessarily. Because some cubic functions do this number. We've seen that before in algebra, right? That function one-to-one? No. 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 It's not one-to-one. We're going to put my Riley, what do you do with my pen? What do you do with my stylus, Riley? Alright. So do we need to know the verbatim definition of a one-to-one function? No. However, comma, you're going to hear however, comma a lot, right, Wyatt? Already have. However, you need to be able to manipulate, to know, have a working definition in your head to be able to reason with that definition. Okay? Now, let's test this function and see if it's one-to-one. Is the function f of x equals the square root of x plus 1? Is that a one-to-one function? So we do that algebraically. We say, let a and b not be non-negative real numbers with f of a equal to f of b. I'm applying the definition to my scenario, yes? I am saying, let these two things be equal. Now, what will tell me if this is an even function? Or, I'm sorry, a one-to-one function. Let's go back to the definition. Oh, they got it right here. If I go through my algebra and I find out that A must equal B, then guess what? One-to-one. If I have a scenario where A does not necessarily equal B, then not so much, right? So, let's do this one. The square root of A plus 1 equals the square root of B plus 1. Can I subtract B, or I'm sorry, 1 from both sides? Minus 1, right? Then I get the square root of A equals square root of B. What do I do now? Square them both. So now, I square them both. And then what do I get? A equals B. Winner, winner, chicken dinner. Winner, winner, chicken dinner. Okay? How about this guy? Henry's already got an intuition because it's a parabola, right? But let's do the algebra. Let's do the algebra. So a squared plus 1 equals b squared plus 1. What am I doing again? I am saying, okay, let's set a squared, let's put f of a, I'm saying f of a equals f of b. I am saying that. So that is one of my stipulations. And then I'm asking myself, is a equal to b? Right? Some people skip, that's all, yeah. Alright, so, subtract 1 from both sides, right? And I get a squared equals b squared. Now what do I do? Square root of both sides. And what happens? Does it? Plus or minus. Why didn't it work up here? I got square roots up here. Why am I not playing with plus or minus up there? I am squaring them, that's true. But what did I say? Let A and B be non-negative real numbers. Why? Why? Because all my functions work from the reals to the reals. And if I got a negative number in here, Negative numbers are part of the real numbers, right? But the square root of a negative number, does that put me in the reals? That gets me out of the reals, so I can't do a negative number in here. Can I do a negative number inside that square, or can A be a negative number? Can I square a negative number? When I square, negative numbers in the reals, right? And when I square it, that's also in the reals, right? So, I can do that. I can do that. So now I get plus or minus A plus or minus B. Well, let's say the absolute value of A equals the absolute value of B, right? I could do that, right? Does that necessarily mean that A equals B? No, it could be opposite signs, right? So this is not one-to-one. Not one-to-one. And if I look at, I'm going to go to a graph. Now, I got this on Desmos. And I want to show you on Desmos what this function is. Okay? Check this out. These two things are inverses. The red line, this red line right here. See where my cursor's going? And this blue line right here are inverse functions of one another. And what do you think this line, this purple line right here is? What do we call that function? The identity function. What can you say about the red and the blue line with respect to the purple line? It's reflected about that line. Exactly, Kaylee. Very good. I almost called you Kayla. Kaylee. I'm terrible. I'm so terrible. Do we see how that looks? So, an inverse takes the original function and reflects it about the identity function. Now, let's look at, I'm just going to sketch this up here. Let's look at my parabola and compare it with my identity function. What would if it was an inverse, see how these guys cross at the same place? 1, 1, at 0, 0, and negative 1, right? They cross at those points. So, look at this. My inverse function would cross at 0, 0, cross at 1, 1, right? And it would do this. It just reflects about that line. But what happens down here? Is that a function? It's not. It's not. This, if that was indeed an inverse, this would be the inverse. But is that a function, ladies and gentlemen? Therefore, this does not have an inverse. Okay? This does not have an inverse. So I want to go back and I want to find an inverse algebraically. Okay? I got a 5-step process. Okay? It's pretty simple once we are familiar with the process. First of all, I determine whether a function is one-to-one. So I do the one-to-one function test. So I say, is f of A equal to f of B? I'm not asking that, I'm saying that, right? And then I'm asking, is A equal to B? So I say 5 minus 3 times A over 2 equals 5 minus 3 times B over 2. Right? I am doing the one-to-one function test. Now, I multiply both sides by 2. I can do that, right, Bonnie? Boom, boom. I multiply both sides by 2. Now, I'm going to subtract 5 from both sides. I can do that, right, Caleb? Boom, boom. Those go away. Wyatt, can I multiply both sides by -1? Can't do that? Sure I can. I can multiply both. I just got to make sure I do it to both sides, right? Boom, boom. Divide by 3, both sides. Can I do it, Keely? Boom, boom. Does A equal B? Check. Yes, it does. So, is this a one-to-one function? Dawson?
Yes.
Yes. All right. Now, I am going to do this again, except I am going to replace f of x with the letter y. So now it's y equals 5 minus 3x over 2. Okay? Step 3. Switches. Switches the x's and y's. So now I got x equals 5 minus 3y over 2. And then I solve for y. So I multiply both sides by 2. So 2x equals 5 minus 3y. And then I subtract 5, so 2x minus 5 equals negative 3y. Divide by negative 3, and I get y equals negative 2x minus 5 over 3. Just like that. And then I replace y with f inverse of x. And that, ladies and gentlemen, is the lesson for 1.6. We will get practice tomorrow during our work day, and then we will go into quiz on Friday, and then we will review next week. Have a great day, ladies and gentlemen.